Hello and welcome to another maths video. We're going to get into trigonometry now. I'm going to kick off looking at Year 9 trig. There's a few other goodies in this video today as well. This is part of the trig unit. In terms of the trig unit, we deal with right angle triangles first. So right angle triangles is basically the trig you've done in Year 9. Then we start looking at non-right angled triangle results. So we look at a thing called the unit circle, obtuse angles. What does it mean to have sine of, say, 160 degrees? What does it mean to have cos of 160? Because so far we've only been stuck in these right angle triangles. And then we're going to look further. So the third part of our unit, I suppose, is looking at finding angles, finding lengths on non-right angle triangles. But we start today with right angle triangles. So right angle triangles, all good. Here we are. Let's get into it. So I've got two right angle triangles here, and all the trig is really based around the idea of similar triangles and triangle ratios. So if I label my sides here, let's just say my two right angle triangles, make them similar, 5, 4, and 3. And this one here, this triangle will be double the size, so I'll make that 10, I'll make that 8, and this will be 6. So this one here, twice the size, but the angles stay the same. So it doesn't matter how big or small you make it, the angles alpha and beta should ideally be the same. How trig works, we need to actually label our sides first to give them some names so we can do some operations with them. So we'll start off with this side here. We'll call that the hypotenuse. So the hypotenuse, similar way you've done to Pythagoras. We did Pythagoras' theorem, the hypotenuse opposite that right angle there. So hypotenuse opposite, also the longest side. Other sides we label in terms of the angle. So in terms of the angles I've got here today, I'm looking at alpha here. Opposite alpha, I'm going to call that the opposite. And next to alpha, I call the adjacent. Okay, adjacent is a fancy word for next to. So two things are adjacent, they're next to each other. So my adjacent's next to my angle. Similarly here with beta, next to beta, well, the hypotenuse, it can't be the hypotenuse, so it's going to be this side. Here's the adjacent, the side next to beta. So next to beta here, my adjacent, this is going to be my opposite side of the triangle to beta. So looking at ratios, if I look at my small triangle here, my ratio of, say I took the ratio of opposite over hypotenuse. So opposite over hypotenuse, so this is a small triangle, we'll do a big triangle on this side. If I take opposite on hypotenuse, I get, it's going to be 4 and 5, and that equals 0.8. If I look at my big triangle, this triangle here, if I do, again, opposite over hypotenuse, that's going to be 8 on 10, which is 0.8. And it's no coincidence that these two are the same. Okay, they're similar triangles, the angles are the same, so alpha and beta would be the same. Okay, if I take the other different ratios as well, let's say opposite on hypotenuse I've done, let's say I take the adjacent on the hypotenuse, so adjacent on the hypotenuse, adjacent on the hypotenuse will be 3 on 5, adjacent's 3, that's 0.6. And I do the same on the big triangle, so my adjacent, my hypotenuse is going to be 6 on 10, which is 0.6. And I look at my last ratio, I'll just look at the ratio of the opposite and the adjacent. Opposite, adjacent is going to be 4 on 3. I'm not going to simplify that because I can't really, that's a small triangle, big triangle, opposite on adjacent, opposite on adjacent is 8 on 6, which of course simplifies to 4 on 3. And given the triangles are similar, it's no coincidence that these are all equal to each other. Okay, that is kind of the basis on which trigonometry lies and which it depends on. So yeah, I mean, this triangle is bigger because I multiplied everything by 2. So what I'd be doing, going from small triangle to the big triangle, 4 on 3, I'd just multiply it by 2 to get 8 on 6. So 8 on 6, it's the same ratio, if I simplify it down. Okay. There are names for these ratios, and there are rules results you need to know. And so firstly, in terms of these ratios, I didn't pick them at random. You will look at them, you'll see it's connecting 2 sides, connecting 2 sides, connecting 2 sides. So every combination of 2 sides is there once I flip them upside down. So my first trig ratio, trig rule is sine. And the trig ratio is always defined in terms of some angle. So I call my angle theta. Here I use the angle alpha. Here I use the angle beta. So sine theta equals opposite on hypotenuse. That's a course theorem. Good to know. My next one I have is cosine theta or cos theta. Cosine is, of course, the full name for it. No one writes it out. Is adjacent on hypotenuse. And tan theta is opposite on adjacent. And the fact that these are all equal, depending on how, it doesn't matter how big a triangle is, should blow your mind a little bit. It should be a little bit interesting that these, and crazy that these are all the same. Okay. In terms of my ratios, there is a bit of a shortcut to memorizing them. I use the saying SOHCAHTOA. SOHCAHTOA. How this works is that if I break it down 3 letters at a time, my sine ratio is my opposite on my hypotenuse, my opposite on my hypotenuse. So sine, opposite hypotenuse. Cosine, adjacent hypotenuse. So cosine, adjacent hypotenuse. Tan, a tan ratio, opposite on adjacent. Opposite on adjacent. So SOHCAHTOA, it's good to memorize this. Will save you having to memorize this mess over here. So SOHCAHTOA is your friend. Okay. In terms of looking at a question or two, so setting up, if I have an example and I've got, say, this triangle here, and I want to go through and find x, and this is, let's say it's 3, and this angle here, let's say the angle is 60 degrees. Question-wise, I've got an angle and 2 sides. Every single trig ratio here, sine, cos, tan, is connecting an angle and 2 sides. So one side there, another side there. An angle here, 2 sides. An angle here, and 2 sides. So when I get a question, if my question's got an angle and 2 sides, I'm using trig. Okay. If I had 3 sides, Pythagoras, but I haven't got 3 sides here. I've got 2 sides and an angle, so it's going to be a trig question. Working with my angle here, everything is defined in terms of the angle. So this here's the hypotenuse, nothing new there. This side here is going to be the opposite. So what I'm looking for in doing my trig question, I'm looking for which ratio, sine, cos, or tan, connects my opposite and my hypotenuse. So opposite and hypotenuse, I want opposite, I want hypotenuse, I'm going to be using the sine ratio here. So I'm going to say sine theta is opposite on hypotenuse. My theta here, my angle is 60. So I get sine 60 equals, and sine 60 is going to be x on 3. Opposite on hypotenuse, x on 3. So I want to get x by itself. This is just solving like a normal equation now. Sine 60, if you put that into your calculator, is just a number. The number it is the same as root 3 on 2, I think you'll find, but it is just a number. So treat it like a number. No unknowns, nothing too crazy or scary about it. So solving this, I want to cancel the divided by 3, so I'm multiplying by 3. And I get that when they cancel, x is 3 sine 60. So x is 3 sine 60. That there goes into my calculator. Okay, I'm not sure exactly what it is. It'll be some decimal. Yeah, I haven't got my calculator on me right now, so I'm not going to work it out for you. But that is the value of x there. So x is 3 sine 60. Put that in your calculator, you get a nice decimal approximation. Okay. Grabbing another example. So if I go this is 20 degrees here, and I take this can be my unknown here, x, and this can be, say, 4. Again, I'm connecting two sides and an angle. Two sides and an angle, two sides and an angle. My trigonometry bells should be ringing. Two sides, an angle, trig. Trig. What sides I've got? Let's go through and do some labeling. This side here, the hypotenuse. This side here is next to the angle, so it's the adjacent. Okay, if you need to label the opposite, you can, and then go by elimination, that's fine as well. But I'm dealing with the adjacent here, I'm dealing with the hypotenuse. In terms of what side, what ratio I'm using, SOHCAHTOA, which is a tragedy if you spell it wrong. SOHCAHTOA is your friend. Respect it, know it, get it correct. You know how to spell your friend's name correctly? Please know how to spell SOHCAHTOA correctly. Sides I've got, the adjacent here, the hypotenuse. It's not sine. Sine's opposite the hypotenuse. I don't have the opposite. So none of that opposite business. None of that opposite business. I'm left with cos. Okay, so I'm going to say cos theta equals, and cos theta is my adjacent on my hypotenuse. So here it's x on 4. Okay, or cos 20 equals x on 4. Again, cos 20 uses some number. Okay, what the number is, again, I haven't got my calculator, I don't know. But if you want to get x by itself, multiply both sides by 4. So you get x equals 4 cos 20. And put that into a calculator, hopefully you'll get an answer. Let's see if Spotlight can do it. Let's go 4 cos 20. Doesn't like it. Let's just grab my calculator. Alright. Doesn't like that either. So cos 20, cos, oops, let's just clear that. 20 degrees, we'll take the cos of that and multiply that by 4. So we do get 3.758. So x here is 3.758. If you have a proper calculator, that there just goes straight into the calculator. Okay, let's put that into your calculator. Alright, that's 2 examples done. Things you want to watch out for. Well, let's not use that one. Let's use this line here. Cos 20 is x on 4. And we've got, had sine 60 here was x on 3. Okay, you always want to write down an equation like that. Okay, you're connecting your angle here with your 2 sides. Your angle here with your 2 sides. Okay, that line there, crucial. Always write that down. Looking at another example using that, so I'm just going to write out a few examples for it because it's that important. If you have this angle here and say this angle here is 50, let's make that x, let's make this 6. So again, labeling my sides, angle, two sides, this is my hypotenuse, this is my adjacent. Okay, this here is my opposite. I'm not interested in my opposite here. So write SOHCAHTOA out. I don't have opposite. That's gone. That's gone. I'm using cos again. So cos 50 equals, here it's going to be adjacent on hypotenuse, so it's 6 on x. If I grab another example, and I have, say, 40 degrees here, and I have x and 3. In this case, again, two sides at an angle, so SOHCAHTOA. SOHCAHTOA. What sides I've got? I've got my, this is my hypotenuse here. I don't have that, not interested in my hypotenuse. That's out, and that's out. It's going to be a tan question. The sides I have, I've got the opposite side, and I've got the adjacent side. Opposite on adjacent, so tan 40 is opposite, so x on 3 here. Opposite on adjacent, opposite on adjacent, opposite on adjacent. This brings us to a little bit of an interesting point. We do now have two equations to solve that I haven't actually gone through and solved yet. If you pay attention to these equations, you'll notice on my top equation, my unknown is on the bottom. So my unknown x is on the bottom there, here x is on top. The last two examples I did back over here somewhere, I had x on top in both of them. So solving this, to get x by itself, I would multiply both sides by 3. So solving this one, I would put in my calculator 3 tan 40 to get me a value of x. So x is 3 tan 40, whatever that is. So here we go. In my top example here though, it's a little bit different because x is on the bottom. So x on the bottom, to get x by itself, you could think of flipping both sides. There's a few different algebraic bits and pieces you can do. What I like to do with this kind of thing is flip the x, and the cos 50 over. So I say that x now equals 6 on cos 50. And that I'll put into my calculator. Okay. 6 on cos 50 goes into my calculator. That's because when I have a triangle, there's two places my unknown could be. This is the side, this is the side. My unknown side can be on top or it can be on the bottom. Pay careful attention to the difference between the two. Okay. It'll certainly come up in the examples. If I grab another example, just to illustrate this one more time, if I have an angle of, say, 50 here, and I have side of, well, my hypotenuse can be x, and this can be 7 here. I've got my hypotenuse, I've got my adjacent. So again, SOHCAHTOA. I don't have my opposite. Opposite's not involved in this question. Opposite's out. So I'm left with cos, and I get cos 50 equals adjacent, so 7 on x. So in this case here, x on the bottom, I'm flipping these two over, x equals 7 on cos 50. Okay. Certainly do a few. This difference here is important. It's important you guys are labeling your sides correctly as well. I get this is revision for you. One thing that's not really revision, I don't believe is revision anyway, is this result here. If you have tan theta, we know tan theta is opposite on adjacent. Okay, TOA, opposite on adjacent, SOHCAHTOA. I can actually write tan theta as sine theta on cos theta. That's a little bit fancy. How that works is this. If I have sine theta on cos theta, oops, sine theta I know is opposite on hypotenuse, and dividing by cos theta, which is adjacent on hypotenuse. So this whole thing here is sine, this whole thing here is cos. Okay. Opposite on hypotenuse is sine, soccer. Adjacent on hypotenuse is cos. This is the same as then opposite on hypotenuse divided by adjacent on hypotenuse, which is equal to opposite on hypotenuse times hypotenuse on adjacent, and these will cancel. So we get opposite on adjacent, which is tan theta. A little bit of an extra result in there for you, a little bit of a bonus. Otherwise, guys, I know it's been a long video, I know it's been kind of a very quick brush over, but have a go at some yourselves. Make sure you're paying careful attention to the difference between these two. Pretty crucial in terms of understanding. Thanks for watching, and best of luck with your own examples and work on this.